today. I'm Daniel with Pluralsight, and it's my pleasure to kind of be host, kind of help kick things off today. Obviously, I'm not the reason you're here, but just to get things started, I wanted to take care of a few housekeeping items, just make sure everything's set up for a good experience today. If you're joining us on Zoom, then we will email you a recording of today's webinar in usually a day or two. We get that question a lot. So yes, we are recording, and you can keep an eye on your email inbox to see that link to the recorded version. We are also recording or rather streaming on a lot of Pluralsight social media channels. We're on Facebook right now and Twitter and whatnot. So if you're joining us there, and then once we're done with today's presentation, you can just rewatch it right there. So you don't need to wait for anything if you're joining us on one of those platforms. And another kind of housekeeping item, if you run into any issues with audio, video, definitely send us a message. We'll try to look into them. Most of the time, if you run into some of those issues, I guess specifically if you're on Zoom, just leaving the presentation and rejoining is usually kind of the best way to take care of it. That tends to resolve most issues. So I definitely encourage you to do that. And lastly, Barry has been kind enough to agree to answer some of your questions at the end of his presentation today. So if you have a question that comes up during his presentation, shoot the question over right as it comes to mind. We'd encourage you not to wait till the end, because sometimes we get a lot of questions and we won't be able to get to all of them. So anything that comes up, just shoot the question over. We'll get you in the question queue, and then hopefully Barry can tackle those questions. But I think that covers all the housekeeping. So at this point, I'll turn it over to Barry. He's going to talk today all about building a globally distributed app with Azure Platform as a Service. All right, Barry, take it away.
There you go. Thank you very much, Daniel. And well, I don't have such a cool background as Daniel has, but that's not the point for today, because I have lots of stuff to share. Let me just share my screen right here. We're going to talk about building a global application with Azure Platform as a Service. So, hi, I'm Barry. You have noticed that already. You can find me on Twitter at AzureBarry and also at azurebarry.com. I'm a software architect and developer. And I also have, let me click on that, a podcast nowadays. I always like to plug that, shameless plug. It's called the Developer Weekly Podcast. You can find it in all of your podcast players and at developerweeklypodcast.com. And it is about technology, but also about people behind the technology. So it's a weekly podcast that not only discusses the latest versions of technology, but it's more about the stories behind technology and things like how to troubleshoot, how to learn, things like that. So check that out. And also check out my courses on Pluralsight, of course. I have lots of courses about Azure, HTML, continuous integration, Blazor as well. And this talk right here is kind of based on a course that's called Building a Global App with Azure Platform as a Service. Although the webinar for today is going to pivot from that course a little bit, where we talk about some different services. Now, this sounds like a very difficult topic, as in a distributed application and having that global with Azure, but it really isn't per se. And I'm going to explain why that is. Now, if you remember anything from this webinar today, then it should be this, and that is, don't reinvent the wheel. Keep things simple and utilize the cloud, because the cloud, in this case Azure, it takes care of all the boring stuff, all the plumbing for you, so that you don't have to do that, so that you can work on value, on things that matter, on the applications that actually provide value to your company and to your customers, because that's what you want to do. You don't want to maintain things. You don't want to be writing plumbing. You want the cloud to do that for you. And that's exactly what it does. So let's just first, I always like to take a step back and talk about the context in which we are playing here. And that is Azure. What you see here is an Azure data center, one of its massive, massive data centers. If you can see the scale here with the little cars and the trucks, this thing is massive. And there are lots and lots of these things all around the globe. And these contain server racks and all sorts of things that make Azure work. So your compute is actually stored here. And a thing like this is a hyperscale region data center. The building is about 1 football field in size, and that is large enough to hold 2 jumbo jets, which is absolutely insane. Now, these data centers of Azure, they are becoming smarter and smaller and have a smaller footprint on the earth as well, as in they're becoming more efficient and use less energy. So the storage is better, cooling is better, and they evolve because Microsoft works on that themselves, and they invent new things actually that makes these data centers work better. They also work on an open source hyperscale cloud hardware, which is called Project Olympus. You can look that up on GitHub, and there you can actually participate in the design of these server racks that go into these cloud data centers. Now, I'm not smart enough to actually do that, but feel free to take a look there to see what this is all about. And they do that because they want the cloud and cloud technologies to be open and free and just progress the complete industry there, which is a good thing, of course. Now, it doesn't only house data centers and server racks in these huge buildings that you just saw, but also underwater within data centers in Project Natick that you see here. So they've started a couple of these experiments where they actually house servers in this thing that you see here, which is a data center that's underwater, because Microsoft says that about 60% or something of all users live near a big body of water, either an ocean or a lake or something. So if we can then deploy things like these underwater, which are easier to cool and also physically pretty secure because, it's harder to get to. You have to dive to it and then get into that to actually get to the servers and get to the data. Then that's an easier way to do it. So Azure is huge and has lots of data centers all over the world and lots of regions in which they have multiple data centers. So if you look at this map, for instance, they're covering a large portion of the world, and there's data centers to come, new data centers that are announced already. And that's a good thing. So basically, in most places around the world, you have a data center that is relatively close. They still don't cover a lot of the southern hemisphere, but still, it is all relatively close because data still travels at the speed of light. So, how far is far away? This is a very good coverage already. Now, why do we even use the cloud? We use that because it is easy to use, as in we can spin up services very easily in the cloud. With a click of the button, you have a virtual machine, a Kubernetes cluster, or a database. It's just very easy, which is incredible. And it is scalable as well, as in I can then scale my Kubernetes cluster or create a huge virtual machine out of nothing without buying hardware. And more importantly, I can also scale back. That is one of the big magic points of the cloud, as in if I don't use my virtual machine, I can turn it off or I can scale it down to a smaller size, for instance, so that I can save on costs, which would be impossible in an old school on-premises scenario where I actually bought the hardware and I can't just scale it back because it's there already and I've paid for it already and I keep paying for it in terms of energy and keeping it up and running. Now, in the cloud, you also pay for what you use and not per se for what you own. So let's take an Azure function, for instance, which is a serverless thing that only runs when you actually need it to run, which means you only pay for it when it runs. Now, this is not true for every Azure service, and it's also a bit more complicated than that, but you kind of pay for what you use, which is a good thing because that can mean that you pay less if you're smart about it. So that's the magic of the cloud and the main reasons to use the cloud, in this case, Azure. Now, in Azure, you have lots of services, and I like to categorize them into different categories. And the first one is infrastructure as a service, which are services that you use that you have a lot of control over, but also a lot of responsibility. These are things like virtual machines, Azure storage, and networks like virtual networks, for instance. There are also platform as a service services. These are services that you have a bit less control over, where Azure does a lot of the management for you, but still you can configure them and you can configure their application settings and can configure, for instance, if they run .NET or Java or something else. And these are things like function apps and Azure SQL database, CDN cache for Redis, logic apps, and app service, of course. And then there are software as a service services. And these are services that are ready made. You don't have to deploy your application to it. They are the application. You just consume the application. And these are things like Azure Cognitive Services and Azure IoT Suite. Now, you might think, well, where is this all going? Well, we are going to use, in our scenario today, platform as a service services. So these are things like Azure App Services, Azure Cosmos Database, Cosmos DB database. And Azure does a lot for you with those services, but you still have some control there. Now, let's talk about our global scenario that we are trying to build here with these Azure Platform as a Service services. And that is the scenario of international cookies. International cookies has cookie stores, and cookie stores that sell actual cookies, like chocolate chip cookies, for instance. And Cookie Monster is one of its customers. Sorry, that's just a fun picture to throw in there. And people can go online and then order these cookies through internationalcookies.eu, which is not a real cookie store if you go to it, by the way. So don't actually order a cookie. It doesn't actually work. And the thing is, these cookie stores are all over the world. So our challenge here is to make this thing, this internationalcookies.eu, this web shop for the cookies, globally performant, so that everybody that goes to this shop, wherever they are in the world, should have the same incredible performance. It should be globally available, as in all these regions, this thing should be up and running all of the time. Now, 100% is obviously not realistic, but a decent amount of time. And obviously, it should be secure. We should be able to secure it. So these three big points we're going to try and tackle only with Azure services, just by throwing them out there and basically configuring them. And I'm going to talk about some of these services and show you them in action as well. It's not going to be very complicated demos, but it's just to give you some context of what we're talking about. Now, it's going to be built up, the application internationalcookies.eu, from an ASP.NET Core website, so a .NET 5, let's say, and that runs in an Azure App Services web app, and that uses an Azure Cosmos DB to store and retrieve its data from. And it also uses Azure CDN to make it faster, and it uses Azure Active Directory to be more secure. Now, there's going to be a couple more services to make this work globally, but these are the core services that this whole solution will consist out of. All right, so let's start about talking about Azure App Services web apps, which are the things that then run this ASP.NET Core application. What is web app? Well, in traditional web hosting, you used to have a server, a physical server that's somewhere that runs an operating system like a Windows server or Linux, and a web server like IIS that actually runs the application. And then you have your application that you deploy to it. Now, in web apps, that works slightly different. You still have servers, but they then run the Azure operating system and possibly a web server. But then there's an abstraction layer above there, and that's called the Azure Service Fabric. And that's internally within Azure. And that's the thing that actually makes all of this work. This thing abstracts the hardware, all of these servers, and just runs the application, the web app, in this case, the Azure App Services web app, on there. And it makes sure that it's available, that multiple instances are running. And you don't have to worry about any of that, because App Services Fabric or Azure Service Fabric just makes that work like magic, basically. You just deploy your app to the web app. So in traditional web hosting, you would need to worry about the application because you need to create the application as a developer, but you also needed to worry a little bit about the web server, as in deploying your application there and possibly configuring it with security rules and virtual folders and things like that. And in web apps, you kind of do the same, but a bit less, because you don't have to worry about, um, you don't have to worry about keeping it available and managing the server, because Azure does that for you. You just worry about the application and the Azure App Services web app. Now, what does it do? It hosts web applications and it runs all sorts of applications like .NET, .NET 5 nowadays, .NET Core, Node.js, Python, Java, PHP, and you can even do a couple more. And that is because Microsoft wants everybody to use their cloud, of course. Everybody's welcome because Microsoft Azure is the core business of Microsoft nowadays. It doesn't make money primarily by selling Windows and Office anymore. No, it makes money by selling you Azure credits. So that's why they want everybody to use it, which is good. This thing is up and running 99.95% of the time out of the box without you doing anything. If you spin one Azure web app up, it will be up and running for 99.95%, which is very good. You can also couple custom domains to it, and you can use continuous deployment where you couple uh, Azure DevOps or a GitHub repository to your web app, and then whenever you push some code, it will be deployed to it and run there in production. It can do scaling and automatic scaling as well, and you can create enable authentication authorization on it. It also uses traffic management that we can see later on. And you can also access on-premises data from your Azure App Services web app through things like VPNs and such. Now, how do you deal then with global usage if you have your application running in one of those web apps? Let's say we run that in a web app here in Europe somewhere, and our users are close. That works well. But if our users are a bit further away, that works less well. And that is because of latency. Users that are close have a low latency than users that are further away. And we're talking about milliseconds here, but that still counts. Because latency is the time that it takes the signal, so a request, for instance, to travel across the network. And that is, in theory, with the speed of light over a cable, but it takes lots of hops and goes through routers. It might go up and down to a satellite connection, and that takes milliseconds. It's still very, very fast, but it takes milliseconds. And that adds up because let's say if I have 10 requests that make up the website, one web page of my website, then a latency of 173 milliseconds adds up to 1.7 extra seconds per per one time that I open this website, which is a lot of time for users to wait, right? And usually it takes a lot more than 10 requests. So we want to get rid of that latency. How do we do that? Well, we could deploy web apps in all of the regions that we know our users are to just cover the world, basically. And by doing that, we know that all of our users are then close to one of these web apps, and thereby we can reduce the latency, right? But then there is a problem because an Azure App Services web app has its own DNS name. It has a unique URL that you can go to that web app. So every one of these has a unique URL. So how does the user know to go to, let's say, centralus.azurewebsites.net? Well, we can use a service like Azure Front Door. Now, Azure Front Door is a global service that you can use to route traffic globally, for instance. So Azure Front Door has also its own unique URL, its own unique endpoint, and you can then use that. Now, what does it do? It is not bound to a region where you deploy it. It's a global service, and it probes the health of its endpoints. In this case, its endpoints, its back-end pool, are all of these web apps that I then configure. And then it can do other things like accelerate application performance because it's very good at making HTTP requests faster. And it does URL path-based routing and URL rewrite. It also has a web application firewall, which makes things a lot more secure. And it can route on geographic performance. And that is what we want. We want it to route on geographic performance. And also by default, it's highly available. So what happens then when we use an Azure Front Door? Well, if a user goes to internationalcookies.eu and that custom domain is configured to the Azure front door, it lands there and not at a web app. And then Azure front door knows which web app is closest geographically to that user. So which one has the lowest latency, and it sends the user there. If that web app isn't available anymore, it sends it to the next closest and most performant web app, which is very clever, right? So it's a global performance routing mechanism that we want to use here. Now, Azure Front Door is just one load balancing option. We have more. We also have Azure Traffic Manager, Front Door, like we just saw, Azure Load Balancer, and Azure Application Gateway. I like to just take a moment to talk about what the differences between these are. Let's first look at the type of load balancing. Azure Traffic Manager and Azure Front Door are both regional load balancers, global load balancers, which means that you use these to route global traffic to their endpoints, like we just saw with Front Door. And you do a regional load balancer. So within one region, within Europe, for instance, within West Europe, you would use a load balancer or application gateway because they cannot do the geographically performance routing that we just saw with Front Door. And the next choice between these that you have is the protocol, and that is Traffic Manager and Load Balancer basically can use any traffic protocol. So they can use HTTP, but also other means of traffic, where Front Door and Application Gateway only can use HTTP and HTTPS traffic for now, at least. And then if you want additional features like URL-based routing, SSL termination, and more advanced things like acceleration, then you would also use Front Door or Application Gateway, where Front Door is then the global variant and Application Gateway is then the regional variant. So that's a little segue. But then that was easy because now we've solved our problem, right? We can now route our traffic globally to the most performant web app. So we're done. All right, that's it for this webinar. No, because we also have to deal with data, and that is a bit more complicated usually, but not in this case, because our application works with Azure Cosmos DB. And what we can do with Azure Cosmos DB is replicate it. We'll see that in a minute. So if we have a user that is close to our web app and our web app talks to Azure Cosmos DB that is also deployed next to, let's say, our web app in Europe here, that's fine. That's all fast, of course, because of the latency there. The web app and the Cosmos DB are close together physically, so they will have a low latency and that will be very fast. But then if a user uses the Cosmos DB from a web app that is further away, then that will be slow, of course, due to latency because it is simply further away. Now, let's just take a look at what Cosmos DB actually is. It is this is then a marketing term, distributed massive scale database, which is actually true. And you can use it with several APIs, and that is a unique thing. You can use it with a document DB API, so a SQL API, MongoDB API, Table API, Graph API, Apache, Cassandra API, and I think there's another one as well, which means that there are simply different ways that you can use to actually access the data within Cosmos DB. So if you have a MongoDB running already somewhere, you can simply migrate that data or start using Azure Cosmos DB and then just point your application to that and it will work because it will have the same API surface as MongoDB currently does, which is great, right? Now, Azure Cosmos DB is a document database, so you store documents in it, not rows with columns, not tables with rows and columns. So not relational data, but document data. That means that you do not have a predefined schema upfront, which is a good thing. It also creates indexes for its data automatically, which you can tweak that if you want. And it does geo-replication, which is the thing that we need. We'll see that in a second. And has a very unique SLA, so its uptime. It is up 99.99% of the time by default, but for reads, it will be up 99.999% of the time, which is amazing. And its latency is also extremely low. And it has an SLA on that, where latency on reads is always smaller than 10 milliseconds, and on the writes also smaller than 10 milliseconds, which is what we want. So If we have our Cosmos DB here, what we can then do to speed things up geographically, we can let it geo-replicate to other regions. We can simply enable that by letting it sync to other regions. And the beauty of Cosmos DB is that we can make all of these nodes, all of the replications writable, which is weird, right? Because now we can write to all of these regions. And Cosmos DB then figures out how to sync all of that data so that everybody has the same data in front of itself to serve the application. And you can actually configure how it does that by choosing its consistency level. You can choose strong consistency, where Cosmos DB first replicates the written data to all of its nodes before it lets you do anything else, or eventual consistency, where you write something and then you can read something, but you might not get the written thing back immediately, but it will be written eventually. So it will eventually be consistent. And you can choose depending on your application requirements there. Now, let me show you that in action, just to give you a context of how simple that actually is. Now, this is the Azure portal, and this is the Cosmos DB that we've been talking about. This is actually for national cookies and not for international cookies. Doesn't matter. So here in Cosmos DB, we have the menu replicate data globally. And as you can see here, I've already configured this thing to be replicated in West Europe, Central US, and Australia East. And all of these regions are also writable, which is great, right? And adding a region is very simple. I can simply click it, and then I can choose if it's writable or not. And that's it. Obviously, I need to pay for this. So you have to obviously think about that. But this does allow you to have geographic performance relatively easily because you just configure this and Cosmos DB figures the routing out itself as well. So it figures out where the request to its database came from and then routes to the geographically most performant geo-replica node that performs best. And then I can also choose the consistency level like we just saw in this slide here between strong and eventual. Cool, right? All right, let's go back to these slides quickly. So now we've done app service. We've distributed that all over the world. And also we have writable geo-replicated nodes of Azure Cosmos DB. So we have the application and we have the data. And now we can actually speed it up more to increase our geographic performance by using Azure CDN. Now, what is a CDN? Now, our website has some static data. That's our images of the cookies, for instance. Now, again, if a user uses that from close by, that's not a problem. But if a user uses that from further away, that obviously takes more time because of latency again. What can we do? We can take that data and we can put that close near to all of the other web apps as well. How do we do that? We do that by putting them in CDN points of presence, and that's a POP. So if you feed Azure CDN with your data, so your images and your video files, your static data, JavaScript files, CSS files, it distributes that data into all of its points of presence around the world, which means that your data will then be close to your users, which speed things up. But additionally, it also offloads the loading of that data from your website, which used to serve that data from its local folder, for instance, to the CDN. So now a user gets its image from the CDN that serves it, which frees up CPU cycles from the website, which is cool, right? Let me show you that for a second. Excuse me. I've been talking a lot today, so I have a bit of a throat tickle. Well, Azure CDN, how do you do that? Well, you create an Azure CDN profile, Azure CDN endpoint. You could choose different CDN providers like Verizon, Akamai, and the Microsoft provider as well. And what you then do is you take your data, your static data, and you put that somewhere. For instance, in Azure Blob Storage, you put your images or CSS files in Azure Blob Storage. And once that is coupled to Azure CDN, it then propagates all of that stuff, it replicates it to all of its points of presence all over the world. And Azure CDN, so Verizon, Akamai, and the Microsoft provider, have a lot more points of presence all over the world than it has data centers. So you can be sure that your data will be close to your users. And then in your website, you simply point to Azure CDN instead of to your local folder where you would get your image or um, your static file. So that would look something like this: international cookie.azureedge.net/cookie.jpg, for instance. So that's kind of how simple it is. You put your static data somewhere else, which is coupled to CDN, and then you point to another endpoint to get that data. And that makes it more performant geographically and offloads its loading time to another service, which gives your app service more CPU cycles to do other stuff with. So we now have a geographically distributed application with web apps, distributed writable nodes of Cosmos DB, and an Azure front door, and also now an Azure CDN. So already lots of services there, but it works well, right? And we just have to configure it seems. And we have then the points of presence all over the world. So we have performance and availability kind of covered, right? So performance, we have websites that are now close to the users. Our data is also close to the users. We can read and write data fast, also write data, because Cosmos DB has then its writable nodes. We have things that are available because the web apps are highly available. Cosmos DB is highly available. Azure Front Door is also highly available. And the CDN isn't even critical. If the CDN isn't there, we can always still get the static images from, let's say, the local website. It isn't critical for our application to work. The web app is resilient, like I said. Cosmos DB is resilient. And then front door also load balances based on endpoint health, like I said earlier. As in, it looks at which web app is the most geographically performant. But then if that web app is down, for instance, it then takes a look at the next web app that is most geographically performant. And as we have multiple web apps running there, we increase our availability. So we covered performance and availability. Well, we're almost there, right? We just need security. But before we do that, how do we actually deploy all this stuff to the cloud? Because we have all these services already, lots of stuff, and our application even. We also have that one. And we might want to have multiple environments as well. So we might have a development environment, which has all of these services, and we might want to actually test if this works geographically in our development environment as well, in test and also in acceptance, and of course in production as well. So that's a lot of environments. How are we going to do that? Well, we can do that with something that's called Azure Resource Manager templates. Now, before we talk about that, let's just talk about how Azure resources are stored and managed in Azure. And that is within a subscription, as in Azure resources all fall within a subscription within resource groups. And a resource group is a very simple thing that is not per se bound by a region. Although when you create one, you do choose a region, which then determines where the metadata of that resource group is. And it's a logical group that you use for security and billing. And a resource group that contains all of your services. So for instance, all of our web apps and Cosmos databases, Cosmos DB accounts, it's actually called. Now, a resource group like that, we can script into an Azure Resource Manager template, which is cool. And that's basically just JSON. That's a JSON template, JSON data. So this JSON here describes all of the services and their configuration that is in this resource group here. And we can then use this JSON here to actually deploy it to the cloud. So what do we need to deploy? We need to deploy our application, ASP.NET Core, and then our ARM templates, our Azure Resource Manager templates, which are these JSON files that we can create and generate. We can store all this stuff in GitHub, which I usually do, or in Azure DevOps repos, for instance. That's also another place. And then we can use it with Azure DevOps to actually deploy it. And what is Azure DevOps? Well, you probably know already, but let me just tell you. You can use this to build, test, and deploy your applications with, and to work together on code, and on a backlog, so items that you need to do, to-do items, work items. And it provides continuous integration by continuously building your code when it comes in to see if it all works together, which is a good thing. And you can use it also to run tests against that code, like unit tests and load tests. And then you can deploy your code and your assets, like your Azure Resource Manager templates, to the cloud. And you do that by creating pipelines, and those can become very elaborate. So in our case, we store all our stuff, so our ASP.NET Core application and also our ARM template in GitHub. And what do we do then? Well, we use Azure DevOps to compile all that stuff with continuous integration with a pipeline. And then we have packages that we can then deploy in a release pipeline. And what we then do is we first use the ARM templates in the release pipeline to deploy or update our infrastructure. So the web apps, the Cosmos DB, the front door, all that stuff. We deploy that. That can all be automated. And after that's deployed, we then deploy the web app to there. Now, let me just show a bit of this stuff to give you a bit more context. And we'll take a look at the web apps itself, Azure Front Door for a bit, Cosmos DB we've seen already, and then we test it with GeoPeeker to see if it's actually geographically performant. Let me switch to that. I already see some questions coming in, which is good. If you have more questions, please put them in the Q&A section of Zoom, and then I will get to them after the session. So this here is the resource group that contains all of these, all of the resources for this globally distributed application. So if you can see here, I have multiple web applications, international cookies, Australia, Central US, and also one in West Europe. I have 3 of these. And I also have an Azure Front Door here. And like I said, this thing is a load balancer basically, but a global load balancer. And what you can do is you can configure it by saying, hey, this is my front end domain, which can be a custom domain, of course. And once people hit that, I will want to route to my backend pools, which in my case are web servers, but you can make more as well. And you can create rules based on this thing routes. Let's say if I have a URL/images, I wanted to route to something else, then if I hit a URL /cookies. And then I can do lots of stuff like URL rewrites and acceleration as well. And the fun thing to note is that Azure Front Door also contains a CDN within itself. So you don't per se have to use the separate service Azure CDN because it's also embedded within Azure Front Door. And then, like I said, it also enables you to use an web application firewall, which is something that you really need nowadays. I don't know if you have any experience with putting up a website that is accessible through the internet. You'll see very, very quickly that all sorts of botnets start hitting it with all sorts of URLs that try to hit the admin page and stuff. So you like to filter that out and protect it with a web application firewall. Now, I wanted to show the CDN as well. That is this thing. This is an Azure CDN right here. And it has an endpoint, like you see developerweekly.azureedge.net. And obviously you can make that also into a custom URL there. And what I've done here is I've coupled an Azure storage account, which is this one. It's blobs here. Right. It's basically just Azure blobs that contain images to this thing. And then I can use that from my application really simply. Now, in all of these services, I can click on the export template. I can also do that on the resource group level. And then I can get my Azure Resource Manager template. So the JSON file that we just talked about that actually describes this service and its configuration. And I can use this thing to deploy this service as infrastructure with something like Azure DevOps in an automated way, which is great, right? Now, I'm doing this all wrong, of course, sequence-wise, because what I wanted to do is I wanted to end with this one. This is the front door, and the front door is our main entry point to the rest of the application, and that is with this URL right here. This is the URL of the front door. And when I hit that, it will go to its backend pool, which is these 3 web apps. And it then routes me to the most globally performant one. And in my case, that's the one with that is hosted in West Europe. I know that because I've hard-coded in, or I've created a parameter that we can see the region where the web app is actually running in. So if I use this URL with a service like GeoPeeker, let me just get that out of the way because I have a zoom thingy in the way. There we go. This will take this URL and will hit it from different regions within the world. And I was really hoping that it would be very fast. It is okay. Yeah, so we see, for instance, from Virginia here, it takes 1 millisecond to actually hit it and get a first response. It takes a bit longer to actually paint it for the service, but that's okay. So what we see here in Australia, if I zoom in on it, then we see in Australia, I actually hit the Australia East instance there, which is what we want. And in Ireland, I would expect and hope, yes, that we hit West Europe. So that works as well. And then do we have something in the US? That's California here. I should hit Central US. So there you go. Front door then routes the requests to the geographically most performant application, which is great. So we now have a globally performant, globally available application, but it's not secure yet. So what can we do? Well, we can use authentication with Azure Active Directory. Now, what is Azure Active Directory? It is an identity as a service. So this is basically an identity provider that stores your credentials, takes care of your passwords, your users and all that stuff. And you can just use it to authenticate and authorize your users against an application with. It does a lot of things. It also integrates with your on-premises identity providers, like your on-premises Active Directory. It can sync up with that, for instance. And it can protect cloud and also on-premises applications. Now, it does things like multi-factor authentication, which is great, and also advanced threat detection, which is, for instance, if I log in to my application right now from the Netherlands, and then 1 second later I log in from Australia, then it knows that that's a bit odd, and then it probably asks me for more authentication, for more proof that I'm actually me. For instance, it might ask me, hey, do a multi-factor authentication right now because it's a bit weird that you're doing this, or it might send me an email, for instance. Now, how does that work when an application authenticates using Azure Active Directory? Well, a browser, so a user uses a browser, and then the browser navigates to the website, but the website is protected by Azure Active Directory, so it says, hey, go back and please authenticate at the Azure Active Directory login page. So the browser doesn't actually, or the application doesn't actually serve the login page. No, Azure Active Directory does that, which is a good thing because you don't want to be creating a login page with password recovery, all those rules. It has to be extremely secure as well. Microsoft does a way better job at that, and they have decades of experience at that. So the user authenticates at this Azure Active Directory login page, and that works. And then it sends its security token that it got from that page to the website, to which the website says, thank you, that worked. Here's a cookie so that next time you send me a request, I know that it's you and that you are authenticated. Now, this is just an example of an authentication flow. There are more types of flows as well. Now, how can we secure our app services in this case? Well, we can do that manually with Azure Active Directory or with Azure App Service Authentication and Authorization, which is a feature of Azure App Service, so our web apps. When we do it manually, the browser and the website can have a public space, for instance, the login page there, or other places like the contact page where people don't have to log in, and then a secure place, let's say your order page or something where people do have to log in, which is then secured by Azure Active Directory. If we use the authentication and authorization feature of Azure App Services, then everything is secured by Azure Active Directory, and we do not have that distinction anymore. Basically, Azure Active Directory forms a wall in front of your application, which means that as soon as a user hits it, it has to authenticate there. That's the trade-off there. But so why would you use that authentication and authorization in app service? Well, in manual, you have control over your security, over the granularity, but it is a more advanced setup. It's more complicated to actually do that. And the application needs to change because the application needs to be able to call Azure Active Directory and do this whole handshake thing that we just saw. Where with authentication and authorization of Azure App Service, that is not per se the case because it's a very easy setup. It's basically just a switch that we flip. And the application, therefore, can remain unchanged. So it doesn't have to talk to Azure Active Directory because Active Directory basically stands in front of the application and guards it there. Now, let me try and show you that in action. This is always a very tricky demo that doesn't always go well, so bear with me for a second. Let me just try this one here, for instance. This is one of the web apps that contains the ASP.NET Core application. And in a web app, we have the authentication and authorization feature. Now I can simply flip it on, and then I can choose how folks should authenticate. Now what I want is I want people to log in with Azure Active Directory. So let's do that. Now I can configure that with an express configuration, which should be easy, right? All right, save it. And that should be it. All right, let's see. So now when I would navigate to this web app, I should have to log into it. Which I didn't, I think. See, it's always a tricky thing. Let's see if I actually enabled it. It is on. It is enabled. Might have to. There we go. So now it asks me to sign in with my account. So this should then be an account in this case that is actually allowed into Azure Active Directory, which is my Azure account in this case. Let's see if that actually works. Fingers crossed. Come on, let's do it. Hooray, it actually worked. So with a flip of a switch, I now have to authenticate. And here's a little thingy that I built that when you are authenticated, you can see who's actually authenticated. That's the only thing that I have to change in my application. But apart from that, this application does not talk to Azure Active Directory at all. So the application remains unchanged, but it also means that the complete application is now secured. There's no granularity there. All right. We did it. So now the application is globally performant, globally available, and also secure. We actually built a globally distributed application with Azure Platform as a Service. Woohoo! So what does it consist out of? We have our ASP.NET Core application. We have an Azure Web App. We have Front Door. We have Cosmos DB. We have CDN. We have Azure Active Directory. We have Azure Resource Manager and Azure DevOps. These are all the things that we now use to make this application globally distributed and performant, available, and secure. That was easy, right? Because Azure took care of the boring parts so that we could take care of all the fun things that actually add value to the customer. So that's it. That was it. Please check it out, my podcast, Developer Weekly podcast. And now I will go to the questions, which I've seen a couple come in. And let me stop sharing so that you don't have to look at that thing. All right. Let's see. I see a couple of questions here and we have some time. So if you have more questions, feel free to just type them in still because we have some time. I see one question here from Stephen Krieger. And the question is Azure Service Fabric open source software? Yes, that is actually open source software. So you saw in a slide that it is something that Azure uses itself to run services like Azure App Services. But you can also use it yourself as a standalone thing, as in you can use an Azure service that's called, oh, sorry, it scrolled away. You can use it yourself as a standalone server, which is called Azure Service Fabric. And you can actually download the Azure Service Fabric SDK and use it anywhere else as well, as in on your local machine or in another cloud on premises as well. And it is open source, yes. It is open source. I hope that answers the question. Next question is from Wilson Molano. And the question is it better to put my JavaScript app on a CDN or on a web app? Where's the best place to publish it? So this is basically a question about, I have a static application. I think that's the question. So a JavaScript application that only consists out of some files, basically. Where do you host that? Do you host that in a web app or somewhere else? I wouldn't host that on CDN because there's better options now. There is actually the Azure static web app option, which is specifically meant for this scenario. So you can use that to just publish some a static website that consists out of HTML, JavaScript, or just JavaScript, and some images, for instance. And it hosts that for you. And then you can do things like custom domain, I think also authorization, and a couple other features as well. That's one option. You can also use Azure Blob Storage, and that also has the static website feature. So if you put all these files in Azure Blob Storage and then say this is a static website, then you also have a couple of features like custom domain. And that's extremely cheap to do. It's also extremely fast. It will be very performant there as well. So there are options, but I wouldn't put it on a CDN or on an Azure web app. Next question is from Santiago Rebels. I hope I pronounced that right. And that is, is it really, well, wait, let me just read it for a bit. All right. Is it really worth it to pay for another server that is local to the user just for a couple of milliseconds of latency that you gain there to make it faster? Well, unfortunately, the answer is it depends, of course. If your application really needs to be extremely fast for users locally, everywhere, then that might actually be the case. That might actually be faster. And like I said, latency adds up. So in my example, I said a website that has, let's say, 10 requests, but usually if you load a web page, it has a lot more requests, maybe 20 or 30 even. And if your latency is high, then you have seconds, 3-4 seconds maybe, that you need to wait extra every time you load your website. And that is often unacceptable, especially when your users are on mobile. So it is definitely something to consider. But obviously it depends on your requirements and on the budget that you have. Hope that answers your question. Then the next question is from Jason Muller. Again, I hope I pronounced it well. I know my last name is actually Luijbregts, and I really don't expect anybody to pronounce that well. You have two questions. And the first one is, what changes to your .NET Core application did you have to make? And I assume that has to do with security. Well, in any case, the changes that I had to make this geographically performant, for instance, are 0, because I just talked to Cosmos DB, for instance, and Cosmos DB does the load balancing, the geographic load balancing for me. So I just talk to my main Cosmos DB endpoint, and that's it. I don't have to route geographically or talk to any other Cosmos DB thing. So yeah, I don't have to do anything for that. The only change that I did here to show you who was logged in was to actually take the authentication token out of the cookie there. You get that in an HTTP header, basically, and show that on the screen. That's all what I did there. But apart from that, I really didn't do anything. This is just a very standard ASP.NET Core application. Does nothing to make it more available or more globally performant. And then the next question you have is also, are you saving to Cosmos DB, and give you an example of that data and how to query it? as in from ASP.NET Core. I assume that you mean how to query that from ASP.NET Core. Yeah, I don't actually have Visual Studio on this machine because this is a presentation machine. But yeah, I do write to Cosmos DB as well, of course, because people can place orders, place cookie orders there, and read cookie orders from there as well. So it does that. And I use the Cosmos DB SDK, I think a 3 or something. Not the latest version, but just before that. And when you do that, there's lots of examples on Microsoft Docs that show it's very simple to actually read and write documents on there. So I would say just Google that, and it's very simple. And then the next question is from Jose Serrano. Yeah, and that is, how does Azure compare to the other cloud services like Google and Amazon? That's always an interesting question, of course. Well, and I have a personal opinion about it. I think if you look at Amazon, for instance, it's a very comparable service offering. They also have all of these services. They have different names and different capabilities, but they can offer the same thing as well. But if you were to bet on one of these big players, I would always bet on Microsoft, because this is Microsoft's big thing. They, like I said, they don't really make any money with Windows and Office anymore. It's the cloud. Azure is the whole thing. That's their main business focus here. If this thing fails, Microsoft is done, basically, or they pivot into something that we haven't seen before. I wonder what that would be. So their main focus is this, where the other companies like Amazon, for instance, do a lot of other stuff as well. Like Amazon has lots of businesses, their web shop, books, audiobooks, you name it, they do so many things. And this is just one of their other businesses, a very important business, but still. And Google the same. They also have lots of other things that they do, and this is one of the underpinning services that they offer and use themselves. So therefore, I would say Azure. But hey, look at what you're comfortable with, because the other clouds also play into other ecosystems that people might be more comfortable with as well. If you're comfortable in the Microsoft realm and use Microsoft tools and such, I would definitely say use Azure, because that's the place to go and everything works well together with the tooling, and that's worth a lot. All right. Let's see. We have a couple more questions. I have one here from Mitchell Arthur. And the question is, from the standpoint of monitoring with a service like Application Insights, would you have an instance per region? That's interesting. Or would you want to send all your monitoring data to a single instance in this case? And then Application Insights is a monitoring service that you can use to monitor, let's say, an Azure web app, and that then monitors who uses the web app, the performance of the web app, if there's any errors in there, things like that. And I would say in this case, you would want one Application Insights instance per web app, because you want to make sure that you get all of the data, all of the usage data also of that individual web app right there. And also all of the errors and performance data of that individual web app right there. Now, nowadays, App Insights is a feature of Azure Monitor. So you can then tell App Insights to send all of that data to a log analytics workspace, which can be a central thing somewhere in the world. And it doesn't really matter what the performance there is, because it does that all asynchronously anyway. So you won't feel that from your application standpoint. And then you can then query that from a local space, from let's say Europe or whatever, through Azure Monitor from that log analytics workspace right there. So yeah, application instances per web app, and then have that all send their data to a central log analytics workspace. Let's see, I have a couple more questions here. I have one from Murali Valath. And the question is, what is the best benchmark for distributed data transfer between 4 or 5 locations across the globe? I know the ideal answer would be, it depends, but do you have any customer experience numbers that you could share? Let's see if I understand that all right. as in, right. I think your question is, how many locations would you then need across the globe to serve a global audience? If that's not right, then please tell me, because I think that's your question. I've worked with a couple of global big companies that had large global scale services that literally would serve basically every country. And what we did there was basically serve all of the outskirts of the world. So Europe, one in Australia, in Asia as well, because that's still pretty far away from Australia. That can be at least one in somewhere Central America, if you can, Africa as well, and then one in South America. So that's 6, I believe. So 6 there was our magical number, but I must say we did have a very big budget there. So yes, of course, it depends on your budget as well, and when things are fast enough. But if you really need it to be fast and also globally, locally available for all of these regions, then you would really need to serve all of these regions there as well. Yeah. So in our case, that was 6, but I can't give a blanket answer to what works for every application there. And then another question from Manohar Nikam, and that is, what is the advantage of using CDN as separate service used when front door already offers the same service? Yes. Well, this is just an example that Azure CDN actually can do that and then offload your application. But you're totally right. There is no advantage at all. If you're using front door already, then basically you can use that CDN in there already. But yeah, you're right. So you don't have to use CDN there as a separate service. You can just use the CDN feature within Azure Front Door to do the same thing, to speed it up and to offload your traffic there. And then there's another question from Mike Paukert. I hope I pronounced that well. I'm sorry if I don't. And the question is, we use an on-premises SQL Server with integrated security for users. Is there similar functionality in Cosmos DB using Azure Active Directory? And then I assume that you mean the integrated security for users, right? Or if Cosmos DB does the same thing. Yes, Cosmos DB does actually do the same thing. It does use Azure Active Directory as well. And most services in Azure nowadays are able to authenticate users from Azure Active Directory, but not all of them yet. They're playing a bit of catch up, basically, where they are trying to roll that feature out to all of the servers. But I think Azure Active Directory or Azure Cosmos DB already does that, yes. Let's see. And then I have another one, and I think this will be the last one because we're running out of time. And that is from Jeremy Schaffer or Schaefer. Sorry if I pronounced it wrong. And the question is, how would you use Azure Front Door to switch between a primary and backup region when the backends are utilized by multiple front ends, each using token-based authentication? Oh, geez, let me just think about that and see if I actually understand the question. So how would you use Front Door to switch between a primary and a backup region when the back ends are utilized by multiple front ends, each using token-based authentication? I'm not sure if I completely follow, but Azure Front Door does probe the endpoints within its backend. So let's say I have a couple of web apps there, like I just did here, 3 web apps. It will probe all those things to see which ones are healthy and which ones aren't. And then if one is not healthy, it won't send any traffic to there, and it will send traffic to another one, basically. But maybe your question is about having, let's say, a standby region, also a standby, let's say, a backend pool that contains a couple other web apps in another region, maybe, and that you can have front door route to that. But it doesn't really work like that. So it always does active, basically. So it always looks for healthy endpoints, and it will then just route traffic to those healthy endpoints based on your other routing rules, like geographic performance routing, for instance. So, yeah, I don't know if that was an answer to your question, and I hope that helped. All right, I think that's it for our time. I hope everybody enjoyed this, and I hope that I was able to answer your questions. Thank you very much for attending, and hopefully, till next time.
Thank you so much, Barry. Really appreciate all that great content that you covered. Just a couple of quick housekeeping items before we close it up. Number one, I did get a few other questions. And so to confirm, if you're joining us on Zoom, you will receive an email with a link to this recording. And we'll also get you a copy of the slides that Barry shared today and some of those resources. I also dropped a link if you're interested in signing up for additional Pluralsight webinars. We offer free webinars, usually a couple times a month. You can go to the URL pluralsight.watch, and that will take you to a form that you can fill out if you want some email reminders about those upcoming webinars. And we usually, Barry does a webinar with us every couple months. So we'll hopefully get him to help us out and do another webinar again soon. And with that, Barry, I wanted to give you just maybe a final opportunity to leave like one last takeaway with everyone that's here.
Yeah, like I said in the beginning of the presentation, if you remember one thing of this presentation is that you let the cloud do most of the work for you. So all these platform as a service services, they do so many things for you. Like we just saw, it does all the geographic routing and availability basically for me without me doing anything from the application. And you should leverage that because you don't want to write all of that very complicated code and manage all that stuff. So use the cloud and don't reinvent the wheel.
Awesome. I love that. Well, thanks again. Thanks everyone who joined us on social media, on Zoom, and I hope everyone has a great rest of